As we go on to topic 2 now of module 5, the old number was 8.2. We're going to look at what is called the quadratic formula. And in section 1, we went over solving equations, quadratic equations, by completing the square. And if we take this formula, that is the standard form of the quadratic equation, and we solve for the letter x by completing the square, it starts off like this. We're going to take our c term and bring that c term over to the other side. And then we're going to divide by a and do a few things. In fact, if we look at the textbook page here, we see that the quadratic formula is written up in topic 5.2. And if we look through it, there's our formula, the quadratic formula in standard form. And they're going to transpose the letter C to the other side, divide everything by A, so here the A's cancel out, and then take half of the B term and go through this procedure. I'm not going to go through it all in detail, but eventually, here are all the steps. You then get x equals something using the letters A, B, and C. So this is the quadratic formula. Now if you looked at the video I prepared using the textbook, I go through all these examples that are there. But we're going to use our mini lecture. So we'll ask you to take some notes as we work these out. So our first example right here is this in standard form. Remember, standard form is ax squared plus bx plus c equals 0. And your answer should be no. But we can put this in standard form, so let's do that over here. 3x squared plus 11x. Now I'm going to transpose the 4. That's a negative 4 equals 0. Now, in order to use the quadratic formula, we have to identify what is our a term, what is our b term, and what is our c term, this a, this b, and this c. So let's do that. So our a term here is a 3. Our b term here is an 11. And our c term here is a negative 4. Now we write the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now what we need to do is to substitute for the letter A, a 3, the letter B, an 11, letter C, a negative 4 into this formula. So let's do it. X equals, now in the formula there is a negative, so we have to put that negative there. And then what is B? B is 11. Then we go plus or minus the square root. Now B is to be squared, so I'm going to put it right in there. 121 minus this minus 4, and put these in parentheses so you really know what you're dealing with. A 3 and then a negative 4. And all of that is going to be over 2 times a, which is 3. So now we simplify. Negative 11 plus or minus the square root. Now when we multiply this, this is a negative 4, looks a little funny. Negative 4 times negative 4 is a positive 16. Times 3 is 48. So this gives me, when I add this together, 169. Now 169, I could do it like so, all over 6. Now 169 is a perfect square. This happens to be a 13. So here I end up with x equals a negative 11 plus or minus 13 all over 6. Well, if I do the negative values first, I get a negative 11, negative 13. That's going to give me a negative 24 over 6, which is going to be a negative 4. Now, if I use the plus value, I get a negative 11 and a plus 13. That's going to give me a plus 2. So I get 2 over 6, which is equal to 1/3. So for letter A, our answer set is a negative 4 and a 1/3. Now, an interesting thing about this one is whenever you get like numbers that are like this and there's no radicals, this could have factored, because these are your answers. So let's see what we could do if we factor that. We don't have a lot of room, but it's taking up lots of space here. So this is going to be 3x. This is going to be an x. And I need an 11 in the middle, so this is going to be a 4 here and a 1 here. And my 11 is positive, so our 4 is positive. And when we solve that, each of these, this is going to be x equals 1/3. And this one, when we transpose, x equals a negative 4. And that's what we got for our answers. So what we're saying is, if you use the quadratic formula, you could solve an equation, again, by putting it in standard form, finding the true values of a, b, and c, putting it into the quadratic formula, and get your answers. And if you get answers like this, this is an indication that you could have factored it. So factoring is probably the easiest way to do it, but the quadratic formula works. Now, for something like this, completing the square, that wouldn't be a good way to go, because you'd have to divide everything by 3, take half of this, and lots of fractions. So the quadratic formula would be the way to go. And of course, this is what they're asking you to do. Okay, as we look at example B now, again, we have to put it in standard form. So let's do it together here. So this is going to be x squared plus 3x, as I remove the parentheses, equals 6x minus 9. Now again, that's not in standard form. So our next step, put it in standard form. Bring this over, this becomes a negative 3x, and this becomes a positive 9. And that equals 0. Now here again we have to identify our A, B, and C. So let's do that by underlining them in red. There's a 1 out there, so our A is 1. Now notice our B now is a negative 3. And our C is a positive 9. So A, B, and C. X equals a negative B plus or minus the square root of B squared minus 4AC all over 2A. So again, I didn't have to write this. We're doing it that if you write it a number of times, then you will hopefully remember it. So X equals, now notice our B itself is a negative 3. So when we put it in the formula, we have the opposite of a negative 3 now makes this a positive 3. So this is a little tricky part here. The opposite of a negative makes it a positive. Plus or minus. Now B is going to be squared, so that's always going to be positive. That is a positive 9. Minus 4. A, we say, is 1. C is 9. All over 2A, and that's 2 times 1, so we can just put the 2 there. So we then get 3 plus or minus. Now a negative 4 times 9 is a negative 36. So a negative 36 and a positive 9 gives us the square root of a negative 27. And that is all over 2. Now you might say, okay, there's my answer. Well, not yet, because notice this is an even index number here, 2, and this is negative. So this is going to be an imaginary number. So we have to do some simplification. X equals 3 plus or minus. Now this, remember, can be factored into the square root of a negative 1. That's going to be the letter I. Then we have the square root of 9 and the square root of 3. So what is the square root of 9? 3. And we said that the square root of negative 1 is I. So we're going to get 3I there. The square root of 3 all over 2. And that should be our answer. Notice we're using some of the things from the previous module. The square root of 27 is always going to be 3, the square root of 3. But since it's a negative underneath there, we had to take out the letter I. Okay. For letter C, we're giving it in function notation. We're saying that function of x equals this, function of x equals 0, so we just take this and equal it to 0, which is what I have here. Now we want to identify our proper A term, B term, and C term. And we do the substitution. X equals a negative B, so the opposite of a negative 5 makes it a positive 5, plus or minus the square root of B squared is 25, minus 4, A is 4, and B is a negative 2. And that's all over 2A, which is 8. Now again, if you have to, put more information in there, that's okay, but after a while you can shorten it to something like this. So we get x equals 5 plus or minus. Now 4 times 4 is 16, and it's going to end up being a positive. So 16 times 2 is 32. So this gives me, under the radical sign, a 57. And it's all over 8. And that happens to be the answer because 57 doesn't have any perfect squares in it. Okay, going on to letter D now. And this looks a little daunting. So here they're saying this and this is going to equal this. So what do we have here? Well, we have 4 plus 3 over x equals 5 over x squared. So remember, we said we could substitute a y here and a y there, and y equals y. We're saying that these equal each other. So there's our, in a sense, function put into a regular equation form. So how do we solve this? Well, we're going to multiply to get rid of our fractions. Our lowest common denominator here is x squared. So we multiply each term by x squared. So here they're going to cancel out. Here one of the x's cancel out, and you're left with a 1. And here nothing cancels out. So we rewrite this. 4x squared plus 3x. Now here this is going to equal 5, but I'm going to transpose it already to put it in standard form. I'm transposing this positive 5 from this side over to this side. So now I'm going to identify my A, B, and C. A, B, and C. And put it into the quadratic formula. X equals, now there is no negative here, so it's just negative is in the formula, -3, plus or minus the square root of b squared is 9, minus 4a, which we say is 4, and c, which we say is a -5. And that's all over 2a, which is 2 times 4 is 8. So we now get -3 plus or minus. Now 4 times, our sign's going to end up positive here. 4 times 4 is 16. 16 times 5 is 80. And when we add 9 to it, we get the square root of 89. All over 8. And that's our answer. Going on to letter, or 2B I should say, or 2A. Example 2. Now here they're saying use a calculator to approximate 3 decimal places, and the solutions is rational numbers. Okay. Now I have a calculator that can actually do this. So I can plug these A into my calculator, B into my calculator, C, and it gives me my values. But if you don't have a calculator that can do it, how would you do it? Well, again, you'd have to use the quadratic formula, and we get something like this. So x equals negative b, which is negative 8, plus or minus the square root of b squared, which is 64, minus 4, a, which is 1, and c, which is 10, all over 2a, which is just going to be 2, since a is 1. All right, so what do we have here? We have x equals negative 8 plus or minus. Now, this is going to be a negative 40. So this leaves us with then the square root of 24. Now, we had said in an earlier lesson, what is the square root of 24? Well, it was the square root of 4 times the square root of 6. And what did we say the square root of 4 is? 2. So our top is going to be, and that's all over 2, it will be x equals a negative 8 plus or minus 2 the square root of 6 all over 2. Now here's a case where you can separate this, and you can put the two under there and the 2 under there. So this now becomes x equals a negative 4 plus or minus the square root of 6. So these cancel out, giving you the negative 4. These cancel out, giving you that. So now what you need to do is put in your calculator a negative 4 minus the square root of 6, and that will give you a value. And the other one is a negative 4 plus the square root of 6, and that will give you a value. And these answers are down below. Now they're saying they want them to 3 decimal places. When I put this into my calculator, I got this big number. So I go here, 1, 2, 3. I look at the 4th place. If it were a 5, I would add 1, but since it's a 4, I drop all of these. And this is the answer for the other. But again, if you have a calculator that will do it, you can just plug in A as 1, B is 8, C is 10, and click enter. Gives you this answer. You have to round it off, of course, and hit it again, and that gives you your other answer. Okay, so this is that one, and the other one is done exactly the same way. Okay.